Hello friends, in this video we will write an assembly language program for the 8051 microcontroller. In this program we have to add a block of data and we have to assume that the sum after the addition of that block of data is an 8-bit number. So let's try to write the program for this. So we are going to write the program to add a block of data. This block of data means that we are given 10 numbers and we have to add those 10 numbers. And we have to assume that after the addition of those 10 numbers, the result is an 8-bit number. So the program statement is like, write a program to add 10 bytes in the internal RAM. We have to add 10 bytes which are present in the internal RAM of the microcontroller. Now we have to assume that the starting location of the block is 40H. Means those 10 numbers are stored from the memory location 40H. Okay, that is the starting memory location. After that, we have to assume that the sum is 8-bit. Means after the addition of those 10 numbers, the sum is an 8-bit number. Then the result is to be stored in register R0 of the bank 1. So this is the problem, and for this we have to write the program. So let us first have an explanation that what we have to do in this program, how we are defining our problem. Okay, so how we are going to solve this? First of all, in the program we are given that we have to add 10 bytes in the internal RAM. So our first thing is we have to consider that a block of 10 bytes is present at location. It is given in the question that we have to assume the starting location of the block as 40H. Okay, and we have to take 10 bytes of the memory. So a block of 10 bytes is present at location 40H. Second thing, we have to add these 10 bytes. So what we will do, because we have to add these 10 bytes, so we have to take a counter, okay, and we have to initialize that counter by the value 10. And we will decrease this counter until its value comes to 0. Okay, because there are 10 numbers and these 10 numbers are to be added. For that, counter is to be initialized. So we will initialize and this count is equal to 10. Then next we have to store the result in register R0 of bank 1. Also, because we are adding two numbers, so one number is to be there in the register, okay, and one number is there in the accumulator. We are adding them, okay. So next thing is register R1 we are taking, and this register R1 will act as pointer to point the block. Okay, so with the help of this register R1 we are pointing towards the block. Every time we are incrementing this pointer and we are adding the numbers. Next is how we will add the numbers. We have to use some instruction. So for addition of two numbers, in the 8051 microcontroller we are having an instruction add. So we will use the instruction using add instruction, add the contents byte by byte. Now we have added the two numbers. First, R1 is pointing towards the block that is 40H. So that number will be added to the next element. So next, how we are adding the numbers? We will again and again we are going to increment this register R1. Also, we have to decrement this count value 10 until it reaches to 0, and when if it is not touching towards 0, again and again we have to add the numbers. So next is decrement the counter. Continue till all the contents are added. Now when we have added all the contents, we have got a result, and now we have to store the result. Okay, so in the question we are given that we have to store the result in register R0 of the bank 1. So we will store the result So this is these are the steps which have to be followed when we are writing the program. Okay, first we will consider 10 bytes of data, then we are going to initialize a counter, then we are going to initialize a pointer also, that is R1 register, then we are going to increment and add the contents and decrement the counter until it reaches to 0 and all the contents are added. And then in the last, if the result is in accumulator, then we have to store that result in the register R0 of bank 1. So for this we will draw the flow chart. In the flow chart, first is the start unit. So this start unit is drawn in an oval shape. After that we are having an arrow, and then in a rectangular blocks. What is our first step? We have to initialize the counter. So initialize counter. Also we have to initialize the memory pointer, okay, because from 40H up till 10 memory location all the 10 numbers are stored. So to point every memory we have to have a memory pointer. So we have to initialize counter and memory pointer. Next is we will first load our result as 0, and in that we are going to add each number. Then take the data using memory pointer. Then do the addition. How we will add? Result will be equal to this initial result, that is 0, plus the number. Then we will check. We are going to increment the memory pointer. So how we will increment? Memory pointer will be equal to memory pointer plus 1. So after increasing the memory pointer, then we will decrement the counter because one number is already added. Now remaining numbers are the 8 numbers. So in this way, after every addition, we are going to decrement the counter. So next step is counter is decremented. Then we will check that whether our counter has become 0 or not. If it is 0, then we are going to store the result. If it is not 0, then we have to repeat the steps that again the result is added with the data. After that, memory pointer is increased. After that, counter is decrement. Again, it is checked that whether the counter is 0 or not. So this is the decision place, that is counter equal to 0. If it is yes, then store the result. If it is no, then repeat the steps. And when we have stored the result, then we have the last step, which is the stop. Stop is again shown in the oval shape. Start and stop, these blocks are shown in the oval. Again, all the others, they are shown in the parallelogram form, in the rectangular form. Okay, so this is the flow chart of the program, that in this way we have to follow the steps, follow the sequence. Now we are going to replace these blocks of the flow chart with the instructions. So let's write the program. So first of all, here it is given that we have to initialize the counter and memory pointer. Okay, and in the explanation we have seen that first of all we have to initialize the register R0. Okay, and the result is to be stored in the register R0 of bank number 1. So first of all, we are going to select the register bank. So first instruction is CLR PSW dot 3 and CLR PSW dot 4. These instructions are written because we want to select the register bank 0. PSW is the program status word of 8051. In this program status word, the third and the fourth bit, they are used for the selection of the register banks. There are 4 register banks in 8051, bank 0, bank 1, bank 2 and bank 3. So if we want to select the register bank 0, then these third and the fourth bit, they are to be 0 and 0. So when these third and fourth bit are 0, 0, then the register bank 0 is selected. So we are using the instruction clear. Clear is going to clear the bit or set, it is going to make its value equal to 0. Okay, so it is going to clear the bit number third of the program status word, and next instruction is going to clear the fourth bit of the program status word. So in this way, when these two bits have become 0, 0, then the register bank 0 is selected. So these two instructions are for the selection of register bank 0. Now after that, when we have selected this register bank 0, then in this bank we are having the register R0, and we have to initialize this register R0 or load it or choose it as the counter. And counter, because there are 10 numbers, 10 bytes of data, so we will initialize it by 10. Now in decimal, 10 is written as 0A. So next step is to move 0A into R0 register. So move R0, and 10 is the immediate data, so we are writing this symbol asterisk and then 0AH. H means that this number is in hexadecimal notation. Okay, so move R0 and 0A. So this 0A will be stored in the R0 register. Then move R1 asterisk 40H. Because we have knowing that these 10 numbers, they are starting from the memory location 40H. So we have to use a memory pointer also. So this memory pointer is the R1 register, and R1 register is loaded with the number 40H. Now we are going to initialize our result also. In our flowchart, we have written that load the result as 0, 0. We know that whenever we are adding two numbers, then one of the operand should be in the accumulator and other operand is our data. So this result or this initialization of the result is in the accumulator. So we are going to move in our accumulator the number 0, 0, H. So this step is to initialize R0 as count. This step is to initialize R1 as memory pointer. And this step is to initialize the result as 0, 0. Now, next steps, because we know in the flow chart, up till this we have done. After that, we have to add the data. Okay, and these three steps are to be repeated again and again. So next step is the addition. We have to add this result with the number which is at this memory location. So how we will add A, and indirect addressing we have to use, so we use the sign asterisk. Okay, so this sign and R1. This is a type of indirect addressing where we are adding the number which is stored in the accumulator and the number which is stored at the memory location which is there in R1. Because in R1 we are having 40H, and at 40H we are having our first number. Now this number is to be added with A. So this is a type of indirect addressing, that in R1 we are having the address of the memory location where the data is stored. Now after that we will increment our memory pointer, that is R1. Then we will decrement our counter. Now, how we will decrement? We have to decrement the counter also, and we have to check also that whether the counter is 0 or not. So for that we will use the instruction DJNZ. This means that decrement the number and check jump up till it is not 0. Okay, means decrement and jump up till it is not 0. So it is going to decrement the R0 register. If it is not 0, it is going to jump at L1, and this L1 label is given at this memory location. You can see in the flowchart also, we are checking that whether the counter is 0 or not. If it is not 0, then again repeat the addition. So these steps are to be repeated. So we are giving a label L1, that if the counter is not 0, then jump to L1 location. J is for jumping, jump if not 0, and D is for decrementing. So decrement this number and jump if it is not 0. Okay, and if it is 0, then after that we have to store the result, because the result is there in the accumulator. After every addition, result is there. So next step will be move, because we have to store the result in the R0 register. So R0 and A. So the result is move in the R0 register. After that, in 8051, after the ending of every program, we write the word end, E-N-D. It means that this is the last statement of the program and it shows that now the program has terminated. So this completes our program. Now let's take an example. We are having 10 bytes of data. So suppose that this block of data is starting from 40H memory location. Suppose the first number is 01. At 41, next number will be 02, 03. This is the block of 10 bytes. Now, in accumulator, we have loaded this accumulator with 00H. Now, first 00 will be added with 01. Okay, so our in accumulator we will get the 01. After that 01 will be added to 02 because our memory pointer will be incremented. 0102, now accumulator will have 03. Then 03, 02, 05 will be there. In this way, the accumulator which is having the result will be added with every next number. And after the addition of all these 10 bytes in the accumulator, we will get 01 plus 02 plus 03. And this is equals to 37H. So our result is 37H. In this way, we are adding the numbers. This is the 10 numbers. So 10 bytes, this counter is loaded in R0 register and the pointer is R1 register. R1 register is incremented so that every next memory location will be pointed, and when these 10 bytes are completed, then this counter will be made 0. Okay, and addition is done using the add instruction. So this is how in 8051 microcontroller we can write a program to add 10 bytes of data, and the sum is assumed to be 8-bit. Only those numbers whose after the addition of those numbers we are getting the result as an 8-bit number. You can see here that we are having all the numbers as 8-bit numbers, and after their addition the sum is also an 8-bit number. Okay. So I hope that this program is now clear to you. Thank you.